I think, came up with this bungee that basically it's a bungee and parachute cord that you can use to wrap or put around the wrap to help hold it tight, to both so it doesn't slip on the colony, but also so that to try to help prevent snow from going down in and getting between the woodenware and the wrap. And one goes on the top and one goes on the bottom. And honestly, several of us, when we started using these, I had 3 colonies in the study, but had 5 or 6 colonies altogether in my apiary. I made them for every colony because they are fantastic. And it makes putting the wrap on so much easier. And it really does try to keep some of that snow out of there. And several of our other participants also made them. So how come I can't advance? There we go. So we had, these are all the different colonies that we had. We had 1 colony in Merrimack that was unwrapped. We had 2 that were wrapped with tar paper. One was in Merrimack County and one was in Hillsborough County. We had 2 that have colony quilts, and I don't know if you guys have seen colony quilts, but basically what they are black plastic with a very thin styrofoam layer inside. It has a R value of about 3.7. So we had 1 in Belknap, which was mine, and we also had 1 up in Grafton County. We had 2 wrapped in different versions of polystyrene. One was 1-inch polystyrene that was in Merrimack County. And then we had 1 that had 1/2-inch polystyrene that was in a marine vinyl. So sort of like, well, it was a homemade bee cozy. We had 3 that were bee cozies. And then 2 that had the colony quilts from like above, but also then had over that a bee cozy. So the total of the R value was much higher. So of these last year, 10 of the 12 colonies made it through the winter. One of those that survived had no queen. And we didn't really see a lot of signs of mold. We did see it in 4 colonies, but it was well below the bees. I think they were all up in the northeast corner, and it was all just some very superficial surface mold. So for some reason, this does not want to advance. There we go. So before we get into some of the results and some background and then some of the results, I wanted to show you what you get if you put these sensors in your colonies. At least the broodminder sensors, you can log on to their website. And once you collect the data, it gives you a lot of different graphs. So this is the graph, all the little blue notes, all the little blue notes are something that Melissa did to help us show and interpret how what the data is telling us. So the dotted pink line is the outside temperature that they get from a weather station. It's not necessarily the one we had. In this case, the dark pink line is the temperature above the lower brood box, and the yellow line is the temperature above the upper brood box. So you can see that the yellow line is it's around 75 degrees. So we can tell that the cluster is up around in the upper brood box. And you can also see these peaks. And if you were to read, I'm not going to go through all the great annotation here, but if you were to read all these little annotations, you would see that these peaks are when it's sunny outside and there's sun hitting the colony, and that's going to help the bees be able to move around. We have several of these annotated graphs up on the website for this project, because if you do this, one of the things that I've found is that it's really it takes a while to really learn how to read these graphs and figure out what it's telling you, other than, oh yeah, the bees, were flying in or out of the hive. You can tell that, but it's really pretty hard to interpret. So Melissa did a really nice job annotating a lot of these to help people start learning about how to read these graphs. So we're going to go backwards a little bit and just do a little background so that everybody's kind of on the same page when we talk about get into some of the results. So just as a reminder, bees, we all know that they cluster, right, in order to survive the cold. And the colder it gets, the tighter that cluster becomes. So bees go into what's called a chill coma, someplace around, some people say 40, some people say 45. I just picked in the middle, around 43 degrees. And when they're in this chill coma, they can't move their flight muscles. If they stay in that chill coma state for 48 hours, they die. They will never be able to recover from that if they don't at least get warmed back up to 50 degrees. So when, so that's why when you see if they break cluster and they get too far away from the cluster and they're out in the corner, they never can be able to move back and warm up. So the other thing is that the harder the bees have to work, we know that the middle of that cluster stays really warm, especially when there's a brood in there. And when they do have brood, they're going to be up to around 90. So the harder those bees have to work to use their flight muscles to keep that cluster warm, that does potentially, they've shown with research that it can shorten the life of a bee. So the oxidative stress of being able to keep that cluster warm can shorten the life. So the harder they have to work, the shorter their life potentially is. The other thing that research has shown is that if you can keep the bees, if the ambient temperature is around 40 degrees, the bees use the least amount of energy to get through the winter. So that means that they don't have to work as hard, they don't have to use as much honey. So that's why people who, when they winter indoors and have a controlled climate, that they try to keep it around 40 degrees. So those are kind of the basics that I'm sure everybody knows, but just as a reminder. The other thing, and when we first started this, I had to go back and remind myself of how R values worked. I mean, we've all heard of R values for insulating our house, right? And so, but I had to really go back and start really thinking about this and how it affects it, because I never thought about my beehive in terms of some of the things going on in the beehive are kind of like in my house. So R value is the measure of how well a barrier resists heat flow. Right. So again, I'm going to put on this little spotlight. Okay. So if you have an R value of 1, right, the sun comes in and some of it will block a little bit of the heat going through, but things will transfer through it. Right. If you have an R value of 2, it takes longer to be able to transfer through. If you put the 1 and the 2 together, it just becomes additive and is 3. Okay. The other key thing here is that heat always transfers from warmer to colder, no matter which direction. So if the sun were on the other side, it would go the other way. So it's always trying to reach equal temperature on all sides. Okay. The other thing that I hadn't thought about is that absolutely everything has an R value. So if you have a frame of honey, that has an R value because it can hold heat, but it also can slow the transfer of heat. So we calculated a medium frame of honey, if it was full, completely full, to be about R of 2.25. So since R values are additive, if you had a super that had 4 frames of honey on each side, one side would be 4 times 0.25. So it'd be R1 and R1 on each side. Okay, the wooden ware that we use in Langstroth hives is about an R factor of 1. Tar paper is almost 0.006. That colony quilt I mentioned is 3.7. So you can see the different R values. So the higher the R value, the slower that heat transfers one way or the other. Okay. Come on. I cannot advance my slide. There we go. Okay, so just trying to apply this to our colonies. So if you have a colony with no insulation, let's just talk about that, right? We have the cluster in the middle. We know that if we have it sunny days, a sunny side, that's heating up this side, and whatever that R factor is, the R1 of the wooden ware, some heat's going to transfer in. On the back side, if it's colder, a lot colder on that back side, heat could transfer out, because remember, heat always goes from warm to cold, right? So we might be transferring some heat in, but it could be transferring out on the backside if this is a lot colder than on the inside. At night in the winter, I can pretty much guarantee that you're going to have, if the cluster is going to be the warmest thing around, and it's going to start radiating heat out of that colony. And on a cloudy day, depending on how warm or cold it is, heat could be going almost any direction. So is this making sense so far to everybody? Hopefully. Okay. So now when we add insulation on the top or the sides, basically what you're doing is you're slowing the transfer of heat in. So if it's really sunny, it's not going to heat up as fast, right? But also any heat that's on the inside, just like in your house, it's not going to transfer out as fast. So I really like to start thinking, I just really started thinking about this very much like my house of, I, in my house, want to keep it as insulated as possible in the winter, because I don't want the heat that is being generated in the house to go outside. And in the summer, I want to keep it, as cool as possible, because I don't want all that heat coming into my house. So at night, again, with having the insulation, it doesn't lose as much heat as fast. And then on a cloudy day, again, you're going to still lose some heat, or maybe some heat will transfer in. Okay, so what did we learn? Let me get rid of this. Okay, what did we learn? So, some of this isn't really that surprising, but we kind of confirmed it. So lower R value wraps transfer more heat into the colony than the high value wraps on a sunny day. So that's not a big surprise. That's pretty common. Oh, come on. Sorry about this, guys. I'm going to just get out of this. Let me see if I start doing this again, if it'll work. There we go. Oh, well, that kind of worked weird, but anyway, so dark wraps that even if they're high R values, right? We hear a lot of times people will say, well, you want to wrap in like tar paper because you don't want too much insulation because the sun won't be able to heat up the hive, and you want to be able to heat up the internal of the hive so that the bees can break cluster and move around. Well, what we did see, and I'm going to show you some of the data, that dark wraps, even though they have a high R value, will heat up when they're exposed to sun, and they heat up the inside of the colony. It heats it up slower, but it still heats it up. And that the high R value wraps slow the transfer of the heat out of the colony. And the other piece is that no wrap prevents heat transfer out of the colony. There is no wrap that we used, even up as high as almost R12, that completely prevented the heat from getting out of the colony. So let me show you some examples of this. So this particular one, this is the 2 hives that had tar paper, and looking at the sensor that was behind the wrap, but on the woodenware. Okay, so this first one had 2 deeps, and it was in filtered sun, so it didn't get direct sun. The yellow line here is the outdoor temperature, so you can see at night here, or 4 in the morning, it was almost 0, but during the day it got up to 35. Let me get a spotlight on here again, because it'd be easier to, sorry, I usually do this in person, so I'm pointing at the screen usually. So up here it's 35. And then as the sun goes down, it starts cooling down. The gray is the temperature on the woodenware. So you can see on the woodenware, we're down to just about the outdoor temperature. And as it starts warming up and the sun starts hitting it, the temperature on the woodenware starts rising. But then it doesn't get up as high as it was in the apiary. Okay, because again, we get filtered sun. So, and then it starts dropping down as the temperature goes down. This other colony has the yellow again, it gets up to almost 40 that day, and for the outdoor temperature, but this is in full sun. So you can see as soon as the sun starts hitting this gray, the woodenware starts warming up. And look at this, at the height, the outdoor temperature is about 42, but on the woodenware, it's actually warmed up to almost 50. So full sun, if you're using especially these lower R value wraps, and you're wanting that sun to affect the inside of the colony, you really need to make sure that you're in full sun, or at least think about that. Now, one of the things that this particular hive, Lily, was dead at this point. So we know that this is not an effect of the bees at all. And in the Mare 1 hive, we know the bees were up at the top. So again, this might have been getting a little bit of temperature, a little bit of heat from the cluster, but most likely not. It was getting very little. So let me see if I can go down again. I have a feeling putting this pointer on is what's messing up my all right, I'm sorry about this. I really can't move right now. There we go. Okay, so this next one. So now you say, all right, well, we know what the outside temperature of the woodenware was. So what happens to the middle of the colony? Okay, so again, same day, but this is the same day. The outdoor temperature is the dotted yellow line. So where we were down to 0, and then we get up to 35, and then you can see it just goes into the next day. The gray was that on the woodenware. The orange is in the middle of the hive. And again, these bees are right at the top of the colony. So the orange is in the middle. So you can see here that the middle of the colony didn't get down as cold as the woodenware. So that's the components inside holding some heat and also heat coming off the cluster. But then as the woodenware, the gray starts heating up, you can see the middle of the colony does too. And then it takes a long time. The middle of the colony doesn't cool down quite as fast because again, some of the components inside are holding heat. Maybe some of there might be some honey or things like that. And then also you have the cluster heat is radiating off the cluster. So you can see that it's a delayed effect, but you do get that effect inside the hive. So that was on a sunny day and that was in filtered sun. So let's take a look at what happens on a cloudy day. So again, you can see this is the yellow is that dotted line. This is a different day, a cloudy day. So the dotted yellow line here gets down to about -5, -10. So it's pretty cold and it gets up to about 30. So the gray is on the woodenware. So you can see the woodenware, those little tiny lines. We're actually below 0 on the woodenware when the outdoor temperatures below 0. The orange line is the one in the middle. So this is the middle of the hive. So you can see the middle of the hive is down to about 1 or 2, but where's the cluster, right? It's up right under the top, up here at 60. So you say, all right, well, that's interesting because, you know, certainly the cluster is giving off heat, but the average temperature during this time in the middle is 10 degrees Fahrenheit. The average temperature up at the top where the cluster is 63 degrees. So if you think about that, and we know that heat always goes to the coldest spot, that this cluster is radiating a lot of heat. So these bees are working really hard to keep that temperature up at 62 or 63, because only if this is a deep, and this is how big is the deep? 9 inches. So, you know, these two sensors are only 9 inches apart and there's a 50-degree difference. So you got to think about how much heat is coming off that cluster. So they're working really hard to keep it warm. This colony survived, no question. This colony survived. So they made it through, but you know they worked pretty hard to keep it warm. So this I thought was so enlightening. And actually, I'll show you one in a little while that I have this year from my colonies, which are bee cozies on those really cold days that we were talking about a couple of weeks ago. A similar thing. So this is in tar paper, but I also had a similar thing happen with a bee cozy too. So now let's go to the other end of the spectrum. So this was a tar paper. So this is like very little insulation on the outside of the hive. So now let's look at the other end where we had the colony quilts with a bee cozy on top of it, which is like an R11.7, so almost an R12. And these were 2 different colonies, both in full sun. This one, again, yellow line is the outdoor temperature. So it went from 10 down to about 8 and then up to 20. So these bees are all at the cluster is at the very top of the colonies. And this is 4 mediums. So the 2 sensors are about 12 inches apart. So look at how warm this gets on the woodenware, even when we start getting sunny. So we actually went from about 10 degrees up to about 50. So that black plastic that between the cozy and the colony quilt, even though it was such a high R value, it really heated up a lot, but it also dropped off. You can see how it drops off as it gets colder and colder. This other colony, which also had the colony, the cozy and the quilt, these bees were not at the top, they were in between. So you notice that this is a lot higher on the woodenware. So what's happening here is that the cluster is generating the heat, and it's actually, we're able to measure it going through that wood out to the sensor. So this is actually the reason that this is so much higher is because this is measuring the heat off the cluster. So it's over near the sensor, but on the inside. I hope that makes sense. And then just to kind of illustrate, and this is in I had 3 colonies in my apiary that were in this study. The one had just a colony quilt, so R3.7. One had polystyrene with marine vinyl around it, so it was about an R5, R6. And then one had a cozy plus a quilt, so that was an R10. So on this particular day, again, the yellow line is the temperature in the apiary. You can see that when it was midday, so 2 or 3 o'clock, the one with the colony quilt, which is the blue, the lowest R value, heated up really fast. The orange one, which is the next highest R value, heated up some. And then the one with the quilt, the highest R value, it also heated up, but much slower and didn't heat up as much. But then as it started getting colder, just exactly like you'd expect, the one with the lowest R value dropped off quickest, and then the other ones did drop off. But you can see even the high R values, they did drop off and got pretty cold. Whoops. Okay. So one of the things that we used a few different places was the FLIR cameras to measure, just to see where, if we were, what was happening if we had heat leaking out of the colonies. So we did learn some interesting things. So that the colony quilt, there are 3.7. So this is what the colony looks like. It's got 4 mediums under the colony quilt, and you can see the bungees at the top and the bottom. So the quilt is the black thing. I also put, because I was having some problems with some snow getting in there, so I just stapled some Reflectix over the top. So it's kind of like a shingle over the top. So I went out one night about 5:45 in the evening and took a FLIR picture of my colony to see what I could see for heat. The outside temperature was about 15 degrees. So up here, this is where the Reflectix is, but you can see red is hot. So this is that colony quilt is hot and radiating heat. White is the hottest. So this is the actual where I have a little tiny upper entrance. It's about 3/8 of an inch square. You can see that's where heat is coming out. Then I went out the next morning, about 12 hours later at 6 a.m., just to took the same picture. So you can see all the heat had dissipated off. So now that it's blue is cold. So there's no more heat on that quilt, but you can still see at the top, that little hole right there is my little tiny upper entrance with heat coming out. And then also heat coming out right here would be heat leaking out from this crack that is between, there's just basically insulation in the top of that box. There's no, this is the inner cover right here. So that this heat is leaking out from that crack right there. So you can really use the FLIR cameras to tell us a lot about if you're losing heat from cracks, which leads to the next thing that we learned in spades, which is holes in the woodenware and gaps matter. It just allows heat to escape all over the place. And I'm going to show you a couple examples. And then the other piece was that bees did a really good job of controlling the humidity. All of these colonies were wrapped up pretty tight and had very little, didn't have a lot of holes in insulation. We did have 4 colonies did have this small amount of surface mold, and up in the northeast corner, 3 of them were mine, and they all had the same size holes, and we'll talk about that. The other one was a colony that only had bottom openings, and again, didn't affect the bees at all because it was well below the bees. So let me show you what I'm talking about gaps matter. So this is, I made this years ago when the bee cozies first came out. I made my own version of a bee cozy, which was a 1/2 inch polystyrene covered with marine vinyl. And you can see, I didn't really pay much attention, but this is the corner. You can see there's big gaps here. So when you take that FLIR picture, again, the white is the hottest. Whoops, sorry. The white is the hottest. You can see heat leaking out all the places I have gaps. And so, for me, I should have put all that together, but again, the faster heat leaks out, the more the bees are going to have to work. So doing the same thing in my colonies, because I put about 3 inches of insulation, I had a bunch of polystyrene insulation in my barn. So I just cut squares and stuck them in a super and stuck them on top of the inner cover. And that's what this is. So I also took off the outer cover, took a picture looking down. So that's what this is. So again, I wasn't particularly careful about making sure my polystyrene fit exactly perfectly in the top. And you can see where here I had heat leaking out because of I just didn't cut it. I didn't cut it square. I just, it fit, so I stuck it in. So again, bees, I was losing heat in different places. So again, it's just very much like my house. If you go around and you want to insulate and find out where all the holes are so that you don't get the cold air in, and that's, very similar here to what we're doing. So Does anyone have any questions at all? Because I'm kind of going through this pretty fast. Do you have any questions?
I don't have anything in the chat.
Okay,
I have, sorry, I have a question.
shoot.
So in your picture with the upper entrance,
Yes.
there's been a lot of discussion about whether an upper entrance loses more heat than it's worth having in terms of venting. And so, I mean, what maybe you're going to get to that, but I thought I'd ask the question.
Actually, it's a perfect lead in, and I've never spoken with you, so and it's actually a really perfect lead in for the next section, because and actually of the follow on too of what I'm looking at this year. So let me go on and then come back. If I don't answer your question from this, then please ask more.
Okay, thank you.
You're welcome. So, speaking of ventilation, right? There's really three kinds of ventilations that we have in our colonies. Single-sided ventilation. So basically, the holes down at the bottom at the lower entrance. And so what happens is air comes in there and then it travels around like in a big circle and then goes back out the same place. That's single-sided ventilation, with just a single opening. Then the other thing that's pretty common, right, that we have is you have a hole at the bottom and a hole at the top, and air comes in the bottom, it goes up through the colony and out the upper entrance. The reason it goes this way is, right, we all know that heat rises. So it's usually the bees are going to be up here. So the heat is going to go around typically this way, unless there's really strong wind. And if the wind can come in, you might reverse it, but generally it goes like this. And then the other thing that we have is cross ventilation. I haven't seen a lot of people doing this in the winter. I know people do it a lot in the summer, but again, air comes in the bottom, goes out, but in the back on the top. Okay. So that was one of the questions. We were like, well, we all have pretty small openings, and they're not all the same, but they're all pretty small openings on these colonies. How much air is really moving through these? So to really figure it out, you need to do this really complicated thermodynamics stuff that I am not capable of doing, but there are some simplifying assumptions that you can make, just to say, let's assume that the clusters, and we know the bees move around, but let's assume the cluster is all the same and everything is all the same, and it doesn't. Let's just look at really simplified how much air, depending on the size of those openings, is moving through. And there's a whole presentation again up on our website that talks about this. But so basically airspeed depends on the difference between the inside and outside temperatures, right? So remember, heat moves from hot to cold. Well, when the heat moves, it's actually moving the air. So the bigger the temperature difference, the faster the heat's going to try to move. And so that's going to create airflow. So the bigger the temperature difference between inside and outside, the more air is going to move. Okay. If you have really small entrances, wherever the smaller entrance is, that's going to affect how much air, if it's on the intake, if it's on the bottom where that air comes in, if it's a small entrance, I can only get so much through. So it means you can only have so much speed of air moving through. If it's at the top, I might have a bunch of air coming in, but it doesn't get moving real fast because I can't get it out. So kind of like water. Think about water. If you have a really small entrance, you can't get the water doesn't rush as fast, right? Or if you have a really small exit, it's going to build up. It doesn't exit as fast. So what we did with these really simplifying equations, what we did was we took all the different size lower entrances and upper entrances and did some calculation. And we left out the one with a single, only the bottom entrance here. So what this is on the y-axis, this is the speed. How many actually it should be cubic inches per minute that it's moving. Okay, so, and then here is what the outside temperature is. We just said, let's assume the cluster is at 60, the inside temperature is at 60. So at 55, we don't have a lot of airflow. At 20, you start seeing the differences. Now this yellow hive, you can see, so the higher the line is, the faster the air is moving. Okay, so this particular hive had 1 by 1/2 inch opening at the bottom and a 1 by 1/2 inch opening at the top. So that hive has quite a bit of air moving through. The one down here, whoops, sorry. The one down here has basically it's a half circle, the lowest one, with it's 1 inch wide by 3/8 of an inch tall, and at the top is a 1/4 by 3/8 of an inch opening. So you can see there's almost no air moving through this one. The bottom one is my hives. This one is the one I said there was a little bit of surface mold in the lower. It was in box 2 out of 4 in the northeast corner. So we did have a little bit of condensation there, but so a lot of, to start answering the question that you asked, you know, how is it good? Does the entrances, especially like an upper entrance, does it cause more problems than helping you? It depends on, you know, which is the classic beekeeping answer. It depends, but in this case, it's on the size of the openings. How big is your bottom opening and how big is your top opening? Okay. And I'm going to show you the next thing that's kind of related to that is, you know, we say gaps matter, right? And so this is up here on the top is the inner cover. And then this is a candy board that I had made a while ago. This was before we started doing all these studies. And, you know, I would always been here, vent, you know, it better not rain on the bees. So when I made my candy board, I said, yeah, I better put a little vent entrance here, right? And then I stapled hardware cloth on the bottom, right? And so this is like 1/8 of an inch. Well, so if you do look at this using those same equations, and in this case, I did 2 deeps, and let's just do a 1/2 inch by a 1/2 inch and 1 by 1.5 down here. So, and then put a candy board on, and then put a candy board, but a 1/16 gap for that hardware cloth. So this is the difference in the airflow. Again, it should be cubic inches. That's a mistake, but it should be cubic inches. So these two, with just adding a little bit of height, really doesn't make a difference. But look, if I put a 1/16 gap from the hardware cloth, look at how much more air goes through that. Okay, you think, yeah, well, does that really matter? Well, this is a graph, and this happened actually 2 different years in a row. One year was to me, and last year was to one of our other beekeepers in the study. So the blue is the bees are up under the inner cover. So this is the temperature graph of all the data. You can see the bees are generally around 60-ish degrees. The yellow dotted line is the outside temperature. It gets down to -10. The orange line is the middle of the hive temperature. So it gets down to about 10. On this day, he added a candy board. That candy board had a very small vent hole in it. And look what happened. All of a sudden, and Melissa saw this and I saw this, and we were both calling this beekeeper saying, hey, what's going on? Something happened to your hives. And because we didn't know we had added a candy board. But you can see just by adding a very small hole in that candy board, look at what happened to the temperature on the cluster. And what happened in his case is he had pulled the wrap up over the hole, but it had dropped back down. And so all of a sudden the bees were losing air out of there. When he fixed that, the temperature recovered back. So it can make a big difference with the vent, having major venting in there. I had a similar thing where my bees, they just started getting crazy cold and I had to block up everything. And this was a couple years ago. Okay. So next, I'm going to talk about what we're doing this year for a study, but which also follows on to that. But so just things to think about, and I know everyone's already wrapped their colonies, and so this is a little late. But you know, in thinking about it for another year, you know, there's a lot of things to think about. You know, not only how much direct sun do you get, but how strong is the colony? A weaker colony might benefit from those higher R value wraps because it's helping slow down that transfer of heat. Where are those openings in the colony? If you don't leave with anything else, remember gaps matter, because that air is just going to go out of the hive, and that warm air is going to go out of the hive. You know, do you have screen bottom boards? Are there gaps between the boxes and the supers? I know some people will tape all those the boxes together, the brood boxes together to get rid of those gaps. Do you have gaps in any of your insulation? So, you know, balancing those variables between all of this is really complicated and complex. So, you know, things that you think you're maybe are helping the colony, like adding a candy board, could actually be hurting the colony. So it's there's a lot of things. And honestly, just my own experience in going through these 2 years of first doing the moisture study and then doing this, I used my hives, I would always wrap my hives and I would always do different things, but I have really changed my whole management strategy since learning and thinking about this in terms of the thermodynamics of my colonies and in thinking about it more like my house. I have my bottom boards are all screen bottom boards, but I run them year round now with an insert in them. I do not open up my screen bottom boards. I keep my I do have upper and lower entrances on most of my colonies, and I keep them extremely small in the winter. I'm probably going to, I've never run insulation on top of my hives in the summer, but I'll probably start doing that this year, or at least trying some of that. So a lot of the things that I've learned in thinking about the thermodynamics of the colonies and how this moves around has really changed not only my winter management, but also how I do things in the summer, trying to keep those bees as much of a constant temperature as possible. So this is the website, New Hampshire honeybeehealth.com has all kinds of stuff. But if you go under winter wrap study, you're going to find this presentation, all hundreds and hundreds of pages of analysis that Melissa and myself did, really looking at diving deep into a lot of stuff that we learned there. It also, a lot of that annotated things that I showed you for the broodminder in there, much deeper look at the airflow movement, all kinds of stuff. So there's lots and lots of stuff there, probably more than you ever want to know, but lots of good stuff. The other thing, and if anybody has seen my previous presentations or any of the presentations we've done, this is actually, you haven't seen this because I just threw this in last night. So as a follow-on to last year's study, you said I was interested in the question you asked someone asked earlier about, well, I always have had top and bottom vents, but some people only run a bottom vent, and does it really matter? Or what should be different? So that's what I'm looking at now, and how does the colony temperature differ between colonies with a single bottom vent and ones with a top and bottom vent? So this is the setup, and whoops, sorry. I'm sorry that my PC is acting up so much here. So these are all the colonies are in my apiary. I have 4 mediums, sort of the similar setup to what we did in the wrap study. 4 mediums, a closed bottom board, and I always put some reflectix around the bottom in case there's any other kind of holes. Lower entrance, and the size of the lower entrance depends on which colony it is, whether it's a single or a double. There's a shim for with weather stripping added for feed, inner cover, super that has about 3 inches of polystyrene insulation in it, and a couple colonies have slatted racks and a couple don't. So what I have is 2 colonies that have just lower entrances, and I have 3 colonies with upper and lower entrances. You can see here that it has this little white plastic thing because my apiary is pretty exposed. So I took a milk bottle and made these little plastic things just to divert air. So the bees can get in and out and the air comes in and out, but I won't have the wind coming in the upper entrance. So this is what I'm looking at now. There are actually 5, do I have it here? No, there are actually 5 sensors in the hive. In the middle here, you can see one of them. So I have one in the middle in the south on frame 5, and then the opposite side on the north. And then in the top, I have a north and south sensor. And then I also have an east sensor in all the colonies. So what I have found so far is I actually can't, if I didn't know the configurations of the colonies, I couldn't tell you what was the difference. The size of the openings were calculated using those same equations so that the airflow in all of them should be approximately the same. And I can't see a difference between the openings. The one interesting thing was that this particular colony that you're looking at, these particular bees are right up at the top now. And as soon as they went to the top, I don't know if you can see this, but right here, there was these, I just bought these shims from Better Bee, and they had a big gigantic vent hole, which I didn't want. So I filled it with that that spray foam insulation. So it was really thick, like, I don't know how thick it was, but really thick. So within a week of the bees coming up to the top, they chewed all of it out and they made their own upper entrance. it doesn't really expose because you can see here, you can just barely see the top. So the bees can get in and out, but they made their own upper entrance. So the one of the two colonies with a lower entrance, the bees decided they wanted their own upper entrance. The other one with a lower entrance, the bees are in the middle, so they have not done that. So the final thing I was going to show you is, this is not as pretty a graph as the others, but to show you what happened in that same colony that a week and a half ago when we had that really cold weather. So the dotted pink line is the outside temperature, and it got down to about -18 here. These pink and blue lines are the sensors in the middle of the hive. So, box 2 for me, because I have mediums. You can see in this middle of the hive here, it got down to about -4 in my colony. The bees were clustered over on the east side here. That's what this red is. And so even on the north and south sensors, so they were clustered more on the east side over by like slot 9. By slot 4 and 5, they were down to about 10. So even though this is with a cozy and everything else, it got pretty darn cold inside that colony that night. So I'm sure everybody was like that, but I just think it was just pretty interesting to see how cold it got. And so back to the questions about the upper and lower entrances. Did I answer your question?
Yeah.
Okay. So the answer is yes. It it depends. I think you can have a lower entrance and you can have upper and lower entrances, but the bigger they are, the more you're going to have air going in and out. And so if you're going to run upper and lower entrances, if one of them's smaller, then you won't have as much air moving through. But I think that is something that you have to look at.
Okay.
And then I do want to mention, I'm not sure if folks know of Etienne Tardif, but he consulted with Melissa and I on this project, pointed us in the direction of the how to calculate the airflow and all that. He has his business is north of 60 beekeeping. And he has all kinds of great information looking at the thermodynamics of colonies and how they keep things. He keeps bees up in the Yukon, which is just, you think we have cold weather. It's really, really interesting. So if you haven't checked out his website, and I think it's Yukon Bees or something like that. But if you look for north of 60 beekeeping, he's got a lot of great stuff on his website. So, and that's it.
That's wonderful, Heather. Thank you so much.
Well, thank you for having me. Whoops.
Oh, that's okay. Thanks for sharing all of this information. And it certainly gives people an idea of maybe what they might want to do and how they want to approach their methods for next year. And this is why we do things like this, to show you not only what people in the Yukon are doing, but what's actually happening here in New Hampshire, and giving you real data as to what's going on, and educate us.
Absolutely.
I have one question though.
Shoot.
Did you use all brood minders or did you use different sensors?
In the RAP study, we used all brood minders. Because we had to go buy them and several of us had them. When we did the previous year, and this again is on that New Hampshire Honeybee Health website, we did the moisture study. We had a variety. We had some broodminder. Basically, we used whatever sensors people had because we didn't buy any. The New Hampshire beekeepers bought sensors for the RAP study. So we had, and I can't remember what kinds they were, to be honest, but it was broodminder and one other kind, and I don't remember off the top of my head what they were. They're in the thing, but we have used the other ones in the past. I was also going to say too, if people were trying to think about this next year and trying to understand about the openings, there's a spreadsheet. I think I put it up on the website. If not, I'm happy to put it up there for running some of those calculations. Or if you're not comfortable doing it and it's something that's pretty straightforward, I can certainly do that and at least give you some indication of what it would mean for airflow of a couple different things. So if people ever wanted to do some what if, just give me a shout and I can either show you how to do that or, and that's good for next year. Well, anytime, but good for next year, really.
I have a question.
Shoot.
How much does the wind affect all of that? I mean, is it the wind versus the sun? Like if you are blocking the wind, you're probably blocking some of the west sun also.
Yeah.
Or...
That's a good question. I mean, so the wind, it affects it in a couple ways, I think. We didn't specifically look at wind, which would be an interesting thing to also add like an anemometer into this. So if you have openings and the wind is, can certainly force more air in or out of the hive, right? If it's coming in the top, it might reverse the airflow, which kind of messes up all the thermodynamics. It also will pull heat away. So if heat wants to go from hot to cold, right? If you constantly have wind pull, and heat is moving over here, but you're having wind like pull the heat away, it's going to keep trying to heat up faster, so you're going to be pulling more heat away from it.
Mhm.
So especially if you don't wrap, or you have like I had where you had that, hardware cloth, that wind is going to be pulling more air away from it. If you're wrapped and your seams are sealed somehow, that it's going to be harder for the wind to do that. I think that's just my own opinion. We haven't really looked at that, but thinking about how wind would affect it, I think that's probably that's at least my opinion of what would happen.
Okay, thank you.
You're welcome.
Anyone else? Okay. Well, the study information is also available on the webpage. So
Yeah, I can put that in the chat while we're talking too, so that people
that's
can just
great.
grab it.
People can just grab it.
Yeah.
So I have a question.
Mhm.
Can I so it is important, you as beekeepers can still do this. If the R value on the top of your beehive is not more than the sides of your beehive right now, you can put polystyrene on your hive, on the top of your hive, so that the cold spot isn't above your bees. It's going to go to the sides of your bees, so the side that has the lesser amount of R value. It's because I think we have some more cold weather coming in the next couple weeks. So, if they're alive, you want to keep them alive.
Yeah.
Got
Yeah,
the
that's a
point, Melissa.
Yeah, that's a really good point. Because so the air comes up, right? And if it hits, if it can go out the top, it's going to want to do that, right? But it's going to go to the easiest place. So if you have a whole bunch of insulation on the top, it's going to hit that and then say, oh, if I go over to the sides, it's going to be easier to move. So then the air goes around and it keeps that warm air inside. That's the basically, it's a great, thank you, Melissa. I didn't even think about that.
It just won't condense when it
Right.
freezes on top of the bees. It will freeze on the walls.
Right.
Okay. Well, thank you again for joining us this evening, Heather. Thank you, Melissa, for all of your work. I know it's a labor of love, to put all of this data together in some kind of a semblance that makes sense to the rest of us. So we appreciate it. We appreciate your work. And I know New Hampshire Beekeepers does also.
Well, thank you. And you guys are always been great support. So thank you so much for that. And also for having me come. I like talking to you guys. So
Yeah. Well, so we'll have to try to get some in-person things going on here soon, hopefully. On another note, back to a little bit of housekeeping here for North Country Beekeepers. We have 2 events coming up that are in conjunction with New Hampshire Beekeepers. I do not have the links yet for registration for them, but I should have them tonight or tomorrow. and I will get them up on the NCBA Facebook page, and I can also put it out in a flash email so everybody has them. March 18th, it's an all-day program. It's going to be held at University of New Hampshire Law School in Concord. And it is called The Business of Beekeeping. So those of you who are hobbyists that are seriously thinking of becoming a little bit larger, maybe not true sideliners, but you're looking at, maybe the possibility down the road to bring your homestead to another level and start doing some selling of your products, this is the program for you. So that's going to be, we've done it before 3 years ago. We're going to be doing it again. And it's a fun program. It's interactive. And the room is a great room. There's plenty of space in between people and lots of ventilation. And so that was one of the reasons we agreed to do it again, was because it was we felt a safe place. The second program is the NHBA March meeting, which is the following Saturday. And that starts at 9 o'clock in the morning. It'll probably run till 12:30. We have Scott McCart from the Cornell Dice Bee Lab, who is going to be speaking to us. And that is a free program. And that link will also be put up on the Facebook page, so you can register for that. Both of them you have to register in advance. So does anybody have any questions about those? Okay. Some of you have been asking about a Beekeeping 102 class from White Mountain Apiary, and we are putting that together. It's going to be hands-on. It won't be via Zoom. It will be all hands-on, and it probably won't start until May, till we can actually be outside and in the hives and open stuff up. And it'll be limited to the number of people, just for safety and health reasons. So that's coming up. I don't know if anybody else is on here from different bee clubs that knows of any other programs that are going on that are open to the beekeepers in New Hampshire. Speak now. All right, then we can do our chat, find out how people are doing. Who wants to go first? Barbara.
Well, I checked them actually yesterday and today. Both of my hives are doing well. They seem to be doing well. They were out flying. Actually, they were in the front of the house today. They weren't even just like around the hives, which surprised me. Yeah, I think they're doing okay. I have put some extra sugar right in the top, underneath my winter box there, just because I wasn't sure. They were very high in the hive, and I was concerned that they were running out of food. So I did that, and they seem to be good. So so far I've got my fingers crossed.
Great. Great. And that's the thing we really want to watch. I mean, you can heft the back of your hive and see if you think that the stores are light from what it felt like in the fall going in, and always add some extra food for them. The other thing you can do is, I know we're going to be having some cold weather still coming up, but these are the time of the year that sometimes we'll have 2 50-degree days in a row. So you may want to think about even doing on those 50-degree days, because there's very little brood in our hives, and doing an OA.
No way. Yeah.
An OA treatment. This is a great time of year to take care of those winter mites that might have, snuck through, and get a good jump start on your spring. So I think, watch your weather, and, the equipment is here. So we've got it if you need it.
Whoops.
Okay, Rick.
So far, excuse me. So far things look good. All the hives at the house are still alive. They were out flying today. Oddly enough, mine were getting substantially further away from the hives than I thought they would as well. They were up on the deck and kind of flying around. So that was actually kind of concerning because they're doing a lot more activity than I would like them to be doing this time of year to extend their lives. But no, things look good. They're starting to get a little light. So sugar boards are all on, and a little bit more sugar got added to a few of them. But so far they look good.
Well,
We're
that's-
down 2 hives. I lost one at, well, I know I lost one up at my brother's house, and there's one that's questionably that I lost at one of the other apiaries, but so far everybody else looks really good. So
Well, you're gonna see probably 2 reasons why some of them are flying a little farther away from the hive this time of year. One is, you know, they're light on their food stores and they're looking for stuff. And the other is attrition. You know, remember, we go into our winters with 30 to 35,000 bees in the hive, and we come out with 12 to 16,000. So
Yeah.
those 20,000 bees have to go somewhere. And they
That's
will.
true.
They'll just go out and die. I mean, we see them in the snow. You see them on the landing boards, but it's stuff we don't usually see in the summer because they're in the grass or
right.
whatever you have down in your bee yard. You know, they go out and they fly and they're done. So could be some attrition too.
Yeah. No, so in your opinion, obviously you see like winter bees, they have to last substantially longer than what we see for kind of a bee lifespan during the summertime. I was kind of thinking the other day, a lot of that is they stay in the hive, they stay clustered up, they stay substantially less active with foraging and everything else, which allows them to kind of last that winter season. This has kind of been an interesting year where we're seeing those 45, 50 degree temperatures on a almost a regular basis, on a weekly basis. So we're seeing a lot more activity than we normally would. What does that do for the life expectancy of some of these? Are these bees aging quicker than they typically would in the winter with this amount of activity?
Well, I don't think that they're aging any quicker. That's my personal feeling.
Yep.
But I do feel that they're using up. I mean, if they're flying, they are eating more. So, you know, we have to watch them. Metabolically, they are different than our summer bees. I mean, their fat bodies are much larger.
Oh, okay.
That's why having them build up so well in the fall with food that is going to help them keep those fat bodies in healthy shape. Things like there's more sterol in sunflowers. And the sterol is like our cholesterol. It'll fatten them up. It'll really help fatten up those bodies for them. And you look at your winter bees in December on a nice day and compare them with what your summer bees look like, there's a huge difference.
Yeah.
There's a huge difference. So, you know, you want to just keep your eye on that. I mean, the main thing is to keep an eye on what they need to eat.
Right.
You know, I did have one beekeeper say, "Oh, so should I put sugar water in to feed them?" Please do not do that this time of year. Don't introduce any extra moisture into the hive. They don't need it. I mean, it's like putting an ice brick in there because it'll freeze, and
Right.
you know, you'll have a nice freezer for them.
Do you mind if I add one other thing, Jan, that I learned actually from Randy Oliver about winter bees, that winter bees their lifespan is determined basically by when they start raising brood. So when they start raising brood and then they're on the clock to die. So yeah, so if that's also part of the reason that you want to try to wait on giving them pollen patties too early, because if they start raising brood, those winter bees aren't going to make it very much longer. So just,
Interesting.
Oh.
yeah.
Yeah, so that's one of the reasons I say wait, until March to get the pollen in there. I mean, by then we have some maple out. The maple's blossoming, so there are some things for them to forage on. Peter,
Let me unmute. Okay, so I have 4 hives, and I'm following Etienne Tardif's recommendations. So I've got my top blocked off, and I put two bee cozies on each hive, and then I wrap them in that metal reflects bubble wrap, aluminized bubble wrap. So I don't get the advantage of heating from the sun, but they're really well insulated. And so I was up there this morning, and I only saw one hive that had clear activity, bees coming out. The others seem to either still be in cluster or not active. So I'm not sure. I left them with what I consider a sufficient stores for winter. I left them with full complement of honey, and then I fed them something like 500 pounds of sugar. But as far as I know, I only have one that's alive today, one that was active today. It never got much above 42, and the other hives weren't active today. And I'm not sure what that means.
that doesn't mean that they're not alive. It just means that they're probably still in cluster. I mean,
They might, that's
Yeah.
exactly what I'm hoping, is that they're
Yeah.
still in cluster, and that it's only really the biggest hive that has sent any out, and they look as if they came out to die, like attrition, like you were talking about.
Yeah.
The other hives were not active today, and I'm not going to open them up to find out.
Well, no, and
why.
I wouldn't, like I sent that email out to everybody saying, please don't bang on your hives.
No,
Don't
I
let them
didn't do anything
cluster.
like, I just made sure I didn't see any signs of rodent activity. I
Right.
looked under them, and I've, like, I have a board. I've pretty much got them insulated very well, but then the insulation comes down and covers the rodent. I have a Man Lake rodent guard, and it covers about maybe half of it. So the bottom of the hive is pretty much open. Okay, it's open except for the rodent guard. Maybe about half the rodent guard is exposed. So there's ample ventilation. And then I've got a board leaning up against it to keep the snow off it, like you suggested. Those are frozen hard down, and I didn't, I tried to move them, but I didn't want to start breaking them loose. So they're, the entrances are fine. I don't have any real way of measuring temperature. I don't have a fluorocam or anything like that. I'm just assuming the insulation is working. It worked for me last year, and I'll see how it works this year, and I'll report back. But I have no temperature devices. But I am following Etienne Tardif's suggestions, which I found, enlightening.
So if you don't have an upper entrance, you're creating a condensing hive. That water is going to have to go somewhere. But if you set it up right, it should go down the outside walls.
It should go down the outside walls and condense at the base.
Right.
And last year I did not have any moisture, any mold in my hives, even though I had done exactly the same thing. So I'm doing the same thing as I did last year, and it worked for me last year. And I'm just going to hope that it works for me this year.
Right.
I'm not going in yet because I've got them insulated right up, and then I've got 2 inches. Most of them have 2 inches of foam board. You know, the pink board. One has 4 inches. The weakest hive I had 4 inches, and then I've got a medium on top of that, and the insulation comes all the way up to the top of the to the hive top, and I've got it strapped down with those bungee cords to hold the reflexit thing onto the hive and tighten all the. I have more than 2.
So you don't
I
have
have
any
about
exposed
4.
spots, right? So that also builds up carbon dioxide. which is a-
Yes, it does, and that. But I think at the bottom that just natural evaporation will take care of that.
That's
Because
okay.
anyway, I'm hoping. I know that one certainly is alive. The other 3 didn't stir today.
I wouldn't worry about it right now.
I'm not going to worry about
We're
it.
still in the dead of winter.
And I know they were well set up to start with, and I'm just going to wait till spring.
Yep.
Can I
Yeah.
add something?
Sure, Joe.
Yes.
I'd rather have the hive build up a higher volume of carbon dioxide. Reason being is by its very nature, carbon dioxide is a better thermal insulator. And basically it will absorb thermal energy, but then carbon dioxide has a unique characteristic to re-emit that thermal energy. Air doesn't do that.
Right. No, you're. So there's a small greenhouse effect going on in the hives.
Exactly. That's what global warming's all about.
Right.
Right. We send heat from the earth up, and the carbon dioxide, brings it back down and re-emits it down to the earth. That's
Right.
what, to build up in the hive, I think it's a good thing. That's why I'm a little skeptical about the upper entrances. I would prefer, just in my opinion, to eliminate upper entrances and revert back to what Jan's called a condensing hive, and let them build it up and let that moisture, flow down the sidewalls.
We did
Yes.
that to half of our hives this year. So,
Yeah,
This is Joe talking. Is this Joe talking?
yeah,
Yes.
he's
Yeah.
in New Hampshire. I'm in Connecticut right
Oh, I
now.
see. Okay.
So-
So
We're in different sections of the New
Peter,
England right now.
I wouldn't worry about that, Peter, about the buildup of carbon dioxide. I mean,
I'm not worried about it. No,
no.
I just think that Tardif's suggestions really, I found it be extremely useful. We have a
Right.
little bit of altitude. We're at about 1,200 feet, and we have some pretty strong winds here. So I've got some windbreaks up and some piles of wood around, and but I've really got them insulated well, according as Mr. Tardif. I was so impressed that he was raising bees in Fairbanks, Alaska. That's like, wow, that's 200. He has over 200 days, 230 or 4 days when the bees are in cluster. I mean, they're only working a third of the year, and he manages to keep them surviving, and that's extraordinary.
We think our season's short.
We think our season is short. My goodness.
Yeah.
Anyway.
He's
I'll
a wealth of
drop back here.
information, and he loves to share all of it, which is great.
Yeah. So I'm gonna mute myself and let someone else talk.
Okay, who wants to step up next? Sam.
Hi, I have two hives right now, and I think they're both still alive. I saw them both flying today. I'm gonna go in tomorrow and check my stores. I didn't have time today, and I think this is a nice tomorrow. But I think they should be okay. I have two candy boards on them with quite a bit of sugar. I put like 16 pounds at the beginning of the season, so that's about it for me.
How about Gwen? Do you have any hives that you wintered over this year? Or are you starting fresh again? Can't hear you.
Yeah, I'm starting over, so
Okay.
nothing to report.
All right. Let's see who else here. Tom.
I'm in Florida.
What a
I'm
guy.
like fingers crossed, but I'm in Florida right now.
How about Melissa? You want to share some of yours? I can't hear her.
My iPad's almost dead.
Oh, okay. I'm sorry.
They seem to be doing pretty well. I had a big cleansing flight, orientation flight, a couple days ago. So everybody seems good. The nukes seem fine. So no pollen going in yet.
So maybe you want to share with the group, how do you configure your nukes to winter over for the winter? You know, 'cause I always promote people to at least start one nuke for themselves to have with their hives, and, you know, for them to know how other people winter over their nukes is probably good. Different methods.
So I think one of the real important things is making sure your queen is the right age. So if you can get, you know, your open mated June queen, I think once you get into July, it's really too late to get them wintered well enough to go through the winter. So I think that's the biggest challenge. I usually winter 5/5, so at least 10 frames. Sometimes I'll do 15. And sometimes I'll do 5. So it really just depends on the hive. And as for honey stores, it's mostly sugar water that they'll get and whatever they can get for themselves. They always get pollen going in the fall or whenever it's necessary. We've had some really bad droughts here. So I usually have to supplement them with frames of honey to make sure they have enough resources for the winter. It's kind of, and I think the airflow pattern that we've worked on last year is really essential for beekeeping, is to understand how much air those nukes need, and whether you do a closed upper entrance. If you are doing those with nukes, then I think having a monitoring system in them, broodminder, works really well. And I had used an Accurite system, which I had bought at Home Depot. And I have like a whole bunch of different systems running, but I did invest quite a large amount of money in the broodminder. So I have everybody under broodminder, and I think they ran out of equipment, so it wasn't available this past fall to buy the broodminder.
Well, that's another note. If people are interested in doing this, to make sure and order your broodminders early.
Yeah, they're
Right.
saying right now that they won't have new temp humidity sensors until 2024. So keep checking. They'll have temperature only, but because I checked it the other day. So.
And having now the temperature and humidity, the humidity tells you quite a lot about your colony, really about your management. And so I stand behind having humidity. I guess that's about
Great
it.
point.
Do you keep the temperature humidity things on all year or
So,
just winter?
so last year, Heather and I were just kind of playing around with having sensors in there and trying to understand our bees for the summer. It's supposed to notify us if our bees swarm. and I wasn't notified. I'm pretty sure my bee swarmed, but it's, you know, it's hard to monitor all these devices all the time. And if you have like 12 instruments running, you're running a whole operation, farming operation. There's just a lot of things going on. But I do study most of it every night, and I really like the equipment. So, and you know, it's Heather's project with the slatted rack versus an unslatted rack. I mean, you can kind of see the difference in how that air flows in the colony. So it's just another gadget, you know, if you're not using slatted racks, to learn about.
Well,
So
and
do you
on
like
that
them, you
note, we
mean?
should have Mary Ellen give her slatted rack.
I've used slatted racks from the beginning.
And see, I
So
had,
you like, yeah.
whoops, I'm sorry.
Go ahead, Heather.
No, I was just gonna say, and I had never used slatted racks. And in working with Melissa, she was like, oh, she always uses them. So last summer I bought a couple, and like she said, we were fooling around with the sensors, just looking at different things. And I could definitely see a difference in the humidity and the humidity in the summer with having the slatted racks versus not, because I had 2 with and 3 without. It's not as obvious this winter to me, but it's interesting. I don't have an opinion yet of good or bad, but I know Melissa and several other people swear by them.
Okay. Gail, do you have any hives going, or did you lose yours?
They
Huh?
didn't live last winter. They didn't live last winter, so we took a year off, but thinking
Okay.
about starting up again this spring.
Okay. Well, let's see. Well, I know Russ and April are starting new. Brenda.
Hello, I started the winter with 5 hives. One nice smallest weakest hive died, I think in November, if I remember rightly. But the other 4 seem to be going good. I have some simple temperature humidity gauges in them. They communicate via Bluetooth, but my techie husband connected them up to a system so I can see a graph of what they're doing. And I just checked and they're buzzing away. Seem to be kind of falls in the hive when they cluster because the sensor is on top of the bars. So as they cluster, they get farther away from the sensor and the temperature goes down. So it's above the ambient temperature outside. So that's how I know they're alive. I haven't checked them visually for several days, a week.
So
I need to go
she-
into the
when
one
she's talking
hive.
about that, Heather, do you feel that having more than 1 or 2 sensors in a hive is an absolute necessary?
An
You know,
absolute
different
necessary,
areas?
an absolute necessary, no, but it's really interesting to have them because you can
Okay.
kind of see them move around. I had one colony where I knew they were in there. I have 5 sensors, but everybody was at 30 degrees. Like every sensor was at 30 degrees. And I'm like, well, I can't tell if they're alive or not. They were somewhere in the hive, way away from the sensors, and all of a sudden they moved, and they're now back in the middle of the hive, and I can tell where the cluster is. So having a sensor is really interesting because it does tell you in the winter a lot about what's going on. Having more than one is great because it just gives you a little more information, but even having one is very useful, I think.
Okay. Let me see who else.
In my
has-
strongest hive, when I checked a week or so ago, they were eating the sugar board. So hopefully later this week, I'll get in there and I'll probably give them some more just because they've eaten the center out. And I kind of feel like I should put some more in the center to replace that. Does that sound great?
Sounds good, as long as you know that they're gonna have enough food. That's the main thing.
Thanks.
Mary Ellen didn't answer before, so I don't know what's up with her. Kim,
Yeah, I'm at 50%. I went in the winter with the 2 hives. My strong hive is still doing real good. Anytime it gets, like a warmer day, like yesterday and today, they're out flying around, and I checked their, lift the back of the hive. They still seem like they have decent stores, but the weaker hive that had just barely requeened themselves in time, it was probably mid to end of October, they didn't make the deep freeze. So,
they didn't make it through that.
no, but I'm happy that the strong one.
We'll keep the fingers crossed. I enjoyed seeing your pictures. Thank you for sharing those with me.
Oh, no problem.
Mike,
Well, for the most part, mine are doing good. I didn't wrap anything this year. So. we'll see
did you
how it works.
insulate?
What's that?
Did you insulate the top?
Yes, I have specially made top covers I made.
Yep.
They're 5.5 inches tall. They got a layer of plywood, then 2 inches of foam with a hole drilled down through for my rapid round feeder and reflective above that. So I can just pop in any day of the week and look down the hole to see if they're there. I don't have to open my hives up. Unless the cluster is off to the side, then you have to wait for the sunny day. But most of them feel heavy. There's 2 that are light out of 50 and 1 that's dead out of 50. And the nukes, some of them took a beating.
Did you have
Not
any
so-
sensors on this year?
Anyway,
Did you have any sensors on yours this year?
no, I've never put a sensor on.
No, okay.
And all my big hives, I actually made like a swing gate in the opening, so I can open them, close them at will. And what's nice about that is if they are open in the spring, I can close them so I don't have to deal with them up top. Go around, close them at night, and the next day they have to come out the bottom.
Yep. Good. Is Mary Ellen back? Did she come back?
I moved the,
I'm here. I had bees flying today. I'm shocked and amazed that I have my resource hives made it through the winter. So they're just little 4-framers.
Are they, do you have them stacked 2 high or 3 high?
Yes, yeah, they have 2. So, but it's the first time I've used a resource hive and tried to overwinter it. So I was pleasantly surprised. So far, so good.
Now, Heather, do you think having that extra layer of woodenware in between them and to have the heat from each cluster in those resource hives, because they're together, makes a difference?
Well, I think that, I mean, they certainly will share heat. I don't know what a resource hive looks like. So are they next to each other or on top of each other?
It's like a 10, it's the exact same size as a 10 frame,
Okay.
but it is divided. So it has 2, the walls that touch each other.
Yeah.
You have 3/4 inch
Mm-hmm.
and then a 3/4 inch right next to it from the other box.
Yeah.
So they each hold 4 frames instead of 5.
Got it. So the heat's going to share between those because the heat will go through that wood. I mean, again, the R value of the wood is 1. So they definitely will share heat. No question. So if one was a little stronger than the other, it would be probably supplying some heat to the other one. And I would bet that those clusters are up against that wood on the inside and sharing heat with each other.
Right. I know mine are.
Mm-hmm.
Yeah, I'm pretty sure mine are doing the same thing.
And I think Melissa had a couple of years ago, she had a really cool floor picture that you were kind of seeing some of that, if I'm recalling Melissa, and I don't know if Melissa can hear me, but I know she had a picture that kind of showed that happening with the floor camera.
I think it's on our moisture study.
Is it on the moisture study? Okay, I'll see if I can find it, I'll send it. I'll send a pointer to you, Jan, and you can get it out to
Okay.
people if they're interested.
Yeah,
Thanks, Melissa.
thank you.
Mary Ellen,
Yeah.
last year I made a double screen board and put my 2 4 frames over a big powerful hive. And they came through the winter beautiful because they had a heated floor.
Oh, right. Yeah.
And all I did was put a medium super on top of the deeps that was full of honey on each. And they went through the winter perfect.
Wow.
It was one of my had to try it moments.
I did not wrap this year. And so that's why I think I was so shocked about the resource hives, because it's not like they're really raging large nukes, you know, they're just, I'd been pulling from them all summer. So I'm impressed. And I didn't put foam insulation above them because I have one of those insulated covers. And I didn't, do you know, Heather, what the R value for those insulated covers are?
I don't right off the top of my head. I don't know if is Melissa still on? Nope, she's not. Melissa might, I don't know off the top of my head what they
Okay.
are. Sorry.
Well, I think
I
it's-
don't wrap my hives. I just put 2 inches of insulation above them. But I don't wrap them or anything. I close the upper entrance because that's what Jan said to do.
Well, it'll be interesting for all of us to compare these notes again in April. You know, and see where all of these different, you know, talk about, remind us of our configurations that we did and how it worked out for us. You know, we also have to remember, I mean, I'm up in Whitefield with that cold snap, had a 65 below wind chill. And, you know, Mary Ellen's down in Somersworth. So, I mean, we have some pretty different extremes as far as weather and weather patterns, even here in our own state. So, you know, it does make a difference, but it's great to hear that everybody's doing this. Appreciate it. Anybody have any other questions or concerns or what's going on? I mean, we've got our March meeting will be coming up the second Monday in March, and then we've got Business of Beekeeping coming up and the NHBA meeting, and then we're into April and doing early splits. So, I mean, we can talk about preparing for splits next month if that's what you guys want to talk about. You want to get on board with that, we can do that. All right. Well, if there's no other questions, I'm gonna, say, yeah. Does that
Good
mean you have a
night.
question, Rick, or is that just a goodbye? Okay.
Thank you.
Thank
you
you.
all.
See
Have
you.
a have a
Thank you
wonderful
again,
night.
Good night.
Heather.
Thank you.
Thank
Thank
you.
you, Heather.
Bye, thank you.
Bye.
Okay, I gotta mute myself and stop my video, Joe, because I'm gonna go check on Mom.
See you later, Janice.
Okay, it's just us. So I'm just gonna go check on Mom real quick.
Joe, you there?
Yeah,
Okay.
she all right?
She's sound asleep.
Good. She breathing all right?
Yeah.